Look at radians and what does a radian actually mean. So in calculus we use radians to calculate angles instead of degrees. So let's just step back and see where does degrees come from. So there's a few reasons why 360 degrees was chosen. If you look at a complete rotation, this is 360 degrees. So why 360 degrees? So the first reason that's probably was used is the rotation of the sun. So what they saw is the sun and the stars rotated around the earth in about 360 days. So it's actually 365.25 days, but it was more or less 360 degrees. And then if you look at the Babylonians, they also looked at using a 60 base number system. So if you look at the 60 base number system, it looks like this. You'll see it goes from 1 to 60, and that's like the first placeholder on this number system, where we're using the decimal system, which comes from 1 to 10, and then move over to the tens placeholder. So if you look at this decimal number system, you'll have ones, tens, and hundreds. So you'll go from 1 to 10, and then you'll have 1, 0, etc. Now in the hexadecimal system, sexadecimal, which the Babylonians used, you'll go from 1 to 60 in the first placeholder, and then move over to the next placeholder, which would be the 60 placeholder. So this will be the ones, the first placeholder, and then this one will be 60. So you'll go from 1 to 59, and then for 60 you'll have the 1 placeholder and then 0 on that placeholder. Of course we don't use 1 and 0s, we use these symbols, but that's what it comes down to. So you count up to 60 before you move over to the next placeholder. And why they used 60 as the number system, it's very divisible. So if you want to divide 10, which is our number system, by 3, so 10 divided by 3, you'll get a decimal. You'll get a decimal number like 0.33. But if you look at the hexadecimal number system, it's very easy to divide 60 by 3, and I'll give you 20. So that's, if you look at 360, you'll see also it's highly divisible. You've got 24 factors in the 360 degrees. So if you've got a circle, this is 360, it's very easy to divide this by 3, and you'll have 3 divided by 360 gives you 120 degrees. So it's very easy to divide 360 degrees into sections. And that's another reason why we are using 60 degrees. That brings us to radians. So what is a radian? So if you look at the circle that we've just shown you now, and we draw this on a plane, we know that we start the calculation always at the 0 axis of the x-axis. And now we can draw a specific angle. So a radian is, if you look at the radius, so the radius is this part here, this will be the radius. If you move along the circle, and the length of this arc, this is called an arc, and the symbol we use for the arc is S. If this length here is exactly the same length as the radius, so this will also be equal to R, then this, and you connect that arc to the midpoint of the circle, this angle here will be exactly 1 radian. So that's 1 radian. So that will be 1 radian. So we'll see 1 radian works out to be more or less 57.3 degrees. So that's approximate. Okay, so you'll see down. Now it's very easy to calculate an angle of any sector. So we've got a sector, and we know what the length is of the radius. So this is 10, and we know the length of the arc, which maybe is 5, we can calculate the angle that's made between this radius and that arc with the formula that we'll use a lot, which is theta equals the s, which is the arc, divided by the radius. So if we use this equation, it's very easy to calculate the arc if we've got the angle and the radius. And you might think this is a very strange formula, but if you look at the circumference of a circle, we know that the circumference of a circle is 2 pi radius. And what we also saw here, that 360 degrees, if you continue with this trend, 360 degrees is actually exactly 2 times pi. Okay, so what it means is, what I saw is, if you take this as radius is 1, and we move one arc there, and we continue this trend through 3, 4, 5, you'd see it would be 6, and then there will be a fraction left, and that is actually 6.24 more or less. And we know that this is very familiar. If we divide this by 2, this is actually 3.14. Oh, sorry, this is 6.28. So that's where we get the 2 times pi for 360 degrees. So if we use 260 degrees and we use this formula and we calculate the circumference, that will be the number of degrees in a full circle, which is 360 degrees, which is 2 pi, multiplied by the radius, r. And you'll see this is exactly the formula that we've been using from primary school to calculate the circumference of a circle. So what we need to remember is, another way to look at this is if you look at a person standing in the middle of a circle, and then we know that this is 10 meters, and then you walk until the end of this 10 meters, and then you walk in an arc for a certain number of meters. If you get to 10 meters, then we know that this arc is actually exactly 1 radius. So this means that you actually don't need any type of measurement for degrees. You can actually just use a piece of string. Someone stands in the middle, you walk on a specific arc for a certain number of steps, and if this is 10 steps long and you walk for 10 steps, this will be exactly 1 radian, which is 57.3 degrees more or less. Okay, so the other formula that we'll use quite a lot is to calculate the area. So to calculate the area, we can use the formula half radius squared times the angle. So again, if we go back, what is the area of a complete circle? We know that a circle's area is equals to pi r squared. So now, if we look at this, we know that a full circle is 360 degrees, but 360 degrees is equal to 2 pi radians. So if we substitute this with 2 pi, and we simplify, half times 2 is 1, so the answer would be 2 pi radian, do that again, it would be pi radius squared. So you'll see that we've actually been using this formula as well to calculate the area of a circle using radians. So to use degrees in this formula won't make sense, because 360 times a radius will give you a very big number, and that doesn't actually mean anything if you look at the angle or the area of the circle. So if we calculate areas, we always use radians. Okay, so let's look at an example. So if we've got, let's say we've got a arc, and we know that this arc has an angle of, or maybe a radius of 30 centimeters, and this is exactly 12 centimeters. Then to calculate the angle, we know that we say it's the arc, which is S, the radius is R, so it's S divided by R. This would be 12 divided by 30, and that would be, let's divide it, let's say this would be 6 over 15 radians or rads. Okay, so remember we talked about that 360 degrees is equal to 2 pi radians. So 180 degree is exactly pi radians. So this is then very easy to use this in calculation. So we can convert degrees easily to radians by using this formula. So let's look at 60 degrees. So if we use 60 degrees, we want to find out how many 60 degrees are there, how many 180 degrees are there in 60 degrees. We divide it by 180 degrees, and for each 80 degree, it will be 1 pi. So we divide it by 180, multiply it by 60, and this will give you 60 over 80, 180 pi, which would be a third pi, or we can just say pi divided by 3. So that is 60 degrees. We can use any degrees. It doesn't have to be a nicely divisible number. It could be like 52 degrees. We'll use exactly the same formula and divide it by 180 degrees, and that will be then 52 divided by 180 multiplied by pi to give you the answer there. Okay, so now we can use this also in applications. So we can have a sector with multiple radians, like this is 5 and this length is 7. Now we can say this is the angle theta, and this, now we can actually say what would be the angle if this arc is maybe, let's make this 5. So to get the angle, remember we say angle is the arc length divided by the radius, and this is 5 divided by 5, which is just 1 radian. Okay, the question could be now that let's calculate the area of this part here, which is the difference between these two sectors. So to get that, we need to get the area of the big sector, which would be half radius squared angle. Remember the radius for the big sector is 7, so it's going to be 7 squared times the angle, which is 1 radius. And the area of the smaller, let's call it the smaller sector, would be a half radians, with radius would be 5 squared times 1 radian. So this would be 25 divided by 2, and this one would be 49 divided by 2. And if we subtract the big area from the small area, we'll get the area of the red area. So this is going to be, the area will then be 49 divided by 2 minus 25 divided by 2, which would give you 24 divided by 2, which would be 12 units squared. So let's say this is a centimeter. If this is centimeter, this will be centimeter squared. And that's how we use radians to calculate circumference and area.